All right, so today we are going to be talking about density. And what density is, it's the amount of matter, the amount of stuff that's present in a given volume of substance. So how much stuff is packed in to a certain amount of space. That's what density is. Okay, it's a characteristic property, which means that you can use it to identify a substance. So iron will always have the same density. Water always has the same density. Water's density is 1 gram per milliliter, which is helpful to know later on. All right, so our density equation is density equals mass over volume. Okay, and what mass is measured in is grams, and our volume is going to be measured in milliliters. Okay, so this is grams over milliliters. So when you write the unit, it's going to look like this: G per ml. All right, that's what our density equation is. All right, so we're going to do our first density example. All right, a student finds that 23.5 milliliters, that's a volume of a liquid, has a mass. It tells you it's a mass, and it's also got grams as our unit, of 35.062. What is the density of the liquid? So we're looking for D. D equals what? So what we're going to do is we're going to start out by writing our formula. D, density, equals mass over volume. Right? And then we're going to plug our information in. So density equals 35.062 grams over our volume, which is up here, of 23.5 milliliters. All right? So what we're going to do, we're just going to put this into our calculator, divide 35.062 divided by 23.5, and we're going to get our answer. Our answer is going to be 1.492 grams per milliliter. Remember that this is going to be your unit, grams per milliliter. All right, so that means that that's liquid has a density that's greater than water. So this would actually sink in water. Awesome. All right, so we wanted to talk a little bit about measuring volume. Measuring mass we do using a balance, and measuring volume can be a little bit trickier. In our graduated cylinder, which is shown right here, we've got this liquid, and you see that there's this curved line, okay? This curved line is called a meniscus. Okay, it's called the meniscus. And what you want to do is you want to read from the bottom of the meniscus, that bottom of the curve. And the reason for that is that this water that climbs up the side, it climbs up the side of the glass because the glass is something called hydrophilic. Okay, hydrophilic. And if you break that down into two words, hydro means water, and philic, like Philia or Philadelphia, right? Philadelphia is the city of brotherly love. Philia means love, okay? So something that's hydrophilic is a water lover. So this glass right here is a water lover. So it pulls that water up and creates a false sense of extra milliliters, right? So that's why we want to always measure from the bottom of that meniscus, right? So you want to get your eye down and level and get it ready to go measuring the bottom of that meniscus. The opposite can also happen, and it happens in mercury with something that's hydrophobic. Okay, and phobic, a phobia, right, is something you don't like, and sometimes you'll see meniscus that looks like that, right? But that's very rare, so it's the opposite. So you would actually measure from the top of that curve, right? But we're not going to worry about those because all the solutions we're working with are going to be hydrophilic. All right, so now I want you to take a few minutes and I want you to try out these two questions. I want you to measure from the bottom of the curve, from the bottom of that meniscus, and I want you to write down what value, what measurement each of these has, okay, for question 1 and for question 2. Make sure you put that in your notes, what you have, all right? All right, so what we are going to do is we're going to talk about displacement now. So what displacement is we've got an amount of liquid, I colored it green to make it easier to see, in our graduated cylinder. And if I look, measure from the bottom of the meniscus, it looks like 51 milliliters are in there. So sometimes when we're measuring volume, we can, for a cube or a normal shape, we can just do, length times width times height. But sometimes we have an unusual shape. So I've got a stopper here, and it looks like a cylinder, but it's a little bit different, okay? So it's thinner at one end and thicker at the other. So something like this would be very hard to find the volume for if we just used calculations. So what I'm going to do is I'm going to do displacement. And what that means is I'm going to take my item and I'm going to drop it into my graduated cylinder, and I'm going to see how much water is displaced by the volume of this. So I've already measured, and it says it's about 56 milliliters. All right, so I'm going to drop this in. I want you to see what happens to the water. All right, so it went up. You guys see how it has taken up space? So it's no longer at 56. It's now up to about 68.5. So it's about 68.5. So what I want you to do is I want you to subtract 68.5 minus your 56, and that would be the volume that our stopper is going to be taking up. So this is one way that you can measure the volume of unusual shapes. You're only limited, by what can fit into your graduated cylinder. Right? So that's measuring by displacement. How much water is displaced? That will be the volume of your item. We're going to do a displacement example now. So a student's medal, okay, that they wear on their neck has a mass of 55.64 grams. So we're going to go over there, we're going to circle it, and we know it's mass. He puts 75.2 milliliters of water into graduated cylinder. So let's draw a picture of that. Oop, I've got a kind of crooked graduated cylinder. That's okay. So that bottom of the meniscus is going to be 75.2 milliliters. Okay, so that's our first volume. And then he puts the metal into the graduated cylinder. Kerplunk. It reads 77.8 milliliters. Okay, so it goes up here. Our bottom of the meniscus, 77.8 milliliters. Right, that's our volume 2. What is the density of the metal? So I write my formula, D equals M over V, and I see what I can fill out. Well, I've got my mass. They gave that to us, so 55.64 grams over our volume. I don't have one volume, I have 2 volumes here, and I've got this picture. All right, so what I'm going to look for is the change in volume. So once the metal gets dropped in, the volume of the water raises up. So we're looking for the change here. And we represent change with that delta V. Okay, the delta, this triangle means change. So we'll do delta V equals 77.8 minus 75.2 equals, right? And that's going to be 2.6 milliliters, right? So now we have a volume right here that we can use to plop into this equation, okay? So let's put our volume in there, 2.6 milliliters. Oh, I apologize, that's not good handwriting. All right, so what I want you to do is I want you to solve for this volume. I want you to tell me what this volume is in your notes. And then I want you to decide, do you think the metal is made out of platinum that has a volume density of 21.4 grams per milliliters, or do you think it's made out of silver that's got a density of 10.5 grams per milliliters? Remember, density is a characteristic property, which means you should be able to tell which metal it is based on the density. So which has a more similar density, platinum or silver? And I want you to write that down in your notes as well. All right? Excellent.